That is kind of frustrating with geometry is that we cannot make assumptions. When we look at a diagram, we have to look at the information that is given and not make any assumptions. So what I want you to do is take some time, you and your table. I want you at the bottom of page 44 to look at this diagram and answer these four. And then on the next page, this E through M, oh, I guess it's the same diagram, isn't it? Yep, same diagram. So you have one diagram to answer questions A through M just based on what you see. Do you know what perpendicular means? Yeah, so true or false? Ready, set, go.
All points are perpendicular.
Yeah. The second one's false. And then every point's on the same thing.
Wait, do I think
Just say true or false.
This is what happens when you
be quiet.
How do you say
the diagram.
It's a Valentino born in That's a good
Wouldn't that be all full frame? But I got making
I is true. A, C, D, and B, C.
Well,
Record A, C,
but the one
This guy, bro, it's so weird.
yeah, they're all on one line.
I feel like she's trying to trick us.
Okay, so then these 1, 2, 3, those would not be.
You're so weird, bro.
What?
I is
So it should be 2
It's so easy.
There's only one false in the top 10. And then there's one on
It does not look like that because there's 3.
I have 1, 2, 3, 4, 5 falses.
Are we counting both pages? Are you
Yeah.
counting both pages?
Yeah.
Oh.
All right. Nolan. A, are all points shown coplanar? Okay, thank you, Nolan. Plus more. Daniel. B, G, and I, collinear. Okay, so here is B, G, I. Not on the same line. Oh. Oh, D, G, I. Doesn't matter. Okay, does it look like we could draw a line through them? Okay, cool story, doesn't matter. There's not a line through them. So they're not collinear. Okay. What about ACH? Those actually live on the same line. Okay. Conway, EG and AH, are they perpendicular?
Yes.
We know that because of this box right here. Right? Okay. Now, next page. Avery, what do you think about BCA and ACD? Are they a linear pair? Yeah. They're adjacent and they form a line. Okay? Now, Will, what do you think about AF? Whoops. AF and BD being perpendicular?
True.
How do you know?
Okay. Because they, like that.
So down here we said, oh, they're perpendicular because of this box. Is there a box over here?
I don't see no box.
So, Will, I agree that it looks like they could be, but without the information that, hey, they are, we can't assume. It's very sad. It's very sad. Okay. Augie, what do you think about EG and BD being parallel?
True, but
So it's false.
So with our eyes, it looks like it could be, but if they did not mark it, we cannot assume. Because you know what they say when you assume. They say don't do it. They say don't do it. Okay. AF and BD are coplanar.
True.
Oh, okay. I was going to ask somebody. Austin.
True.
Thanks. Okay. EG and BD do not intersect.
False.
Why?
Because there's no right angle telling it that'll go straight.
Okay, so if we don't know if they are parallel, then we assume that they're going to intersect. We know parallel lines will not intersect. So if they're not marked parallel, we have to assume, because non-parallel lines we know intersect, that at some point they're going to intersect, we just can't see it. Does that make sense? Okay. AF and BD intersect. We can see their intersection. What is the intersection? Okay. Great. EG and BD are perpendicular. Where's EG? EG and BD are perpendicular? Oh, that's not even close to being something that's true, huh? Okay. All right. ACD, C, and BCF, vertical angles. True. AC and FH are the same line. That is also true. All four of those points are on the same line, so we can name these differently. Okay? I oftentimes have students who get frustrated with this exercise. I know that these two look perpendicular. But if it's not marked, we can't assume. I know that those two look parallel. But if it's not marked, we can't assume it. Okay? All right, go ahead and turn the page. Okay? And we're just going to basically talk about some rules. Okay? First of all, if we have a line that is perpendicular to a plane, it will always be marked. Okay? And what it's going to look like, okay, you remember when we did chapter 1, and if we had a line going through we would see like dotted behind, okay? So if we have a perpendicular line to the plane, it's gonna be marked with that right angle sign, okay? So do your best to draw this picture. Lucas, can you feel that fan blowing? Or did it get unplugged? Okay, so we're going to talk about a couple postulates, okay? Okay, the 2-point postulate. Through any 2 points, there exists exactly one line. So if there are 2 points, we know we can draw exactly one line through it. Okay? Also, if we think about like backwards, if we have a line, then we know there's at least 2 points on it. Okay? 2 points, we can draw a line. A line has to have 2 points, but obviously there's an infinite number of points on a line. Is that what you were going to say, Micah? Did you have a question?
No.
Okay, I thought you raised your hand. Sorry. Okay. 2 lines will always intersect at exactly 1 point. Nothing else can happen. If 2 lines intersect, their intersection is exactly 1 point. Okay. A plane. Okay, same thing. 2 points make 1 line. 3 points make 1 plane, a unique plane. Okay. Now notice, and we've worked on this, we have to have non-collinear points to form a unique plane. Okay. Also, going backwards, 1 plane has at least 3 points. There's going to be a lot of points. Okay. All right, the last 2 at the top of the next page. If 2 points lie in a plane, then the line that goes through them is also in the plane. So here I have D and E. They live in my plane R. Since we have 2 points, we can draw a line through them. Well, now that line also lives in plane R. Okay. All right, and then the last thing, if we have 2 planes intersect, then they intersect in a line. Okay, so what I need you to do, I need you to get out your math folder and turn to page 5. Okay, I just want to give you some examples of the types of problems you might see in your homework. That way you can kind of anticipate how to answer the problems. Okay. Okay, I want to know what postulate is illustrated by the diagram. So look at your list that we just went through and highlighted in your student journal. If this picture, then this picture. Ollie has an idea. I acknowledge that. Let's everybody else catch up to Ollie. Ollie, what's your idea?
2.3.
Yeah, what? 2.3. The line intersection postulate. Okay. If 2 lines intersect, then they intersect at a point. Okay, so how about this second picture? What is this demonstrating? Ollie has it, we know you have it. Let's give somebody else a turn. What do you think, Conway?
2.7.
Okay, and what's 2.7?
Plane intersection postulate.
Okay, the plane intersection. Uh-oh, I'm gonna run out of room. Postulate. If two planes intersect, then they intersect in a line. Okay, so you're gonna have some problems where you're gonna have to look at the pictures and decide what's happening. Okay, you're also gonna have some problems like this. Okay, use the diagram to write examples of our certain postulates. So first, let's look at the plane point postulate. Okay. Can somebody read me the plane point postulate? Micah, can you read it for me?
A plane contains at least 3 non-collinear points.
Okay. So, if a plane contains at least 3 non-collinear points, what plane should we look at? Should we look at Q or P? P. So we can say, oh, that's not what I wanted to use. We can say that plane P contains, he said, 3 non-collinear points. What are 3 non-collinear points in plane P? Micah?
B, A, and C.
A, B, and C. Okay. In a plane, we have at least 3 non-collinear points. Here's plane P. Here are the 3 points in them. Okay. Okay. Let's talk about the plane line postulate. Ty, can you read us the plane line postulate?
If 2 points line planes and line
Okay. So, again, what plane are we going to talk about? Okay. So, plane P, since A and B are in plane P, then we can say that plane P contains line N. Do you see how it's named with this cute little N right here? Okay. All right, turn to the next page. Okay. Something else you're going to need to be able to do is take some information and sketch a picture. So we need TV and PQ intersecting at point W so that TW and WV are congruent. So first of all, what are TV and PQ to be drawn as? I disagree.
Line segments.
Line segments. So first of all, we have 2 line segments intersecting. Does it say anything about the angle at which they're intersecting at? Like, it says nothing about perpendicular, so we don't have to worry about that, okay? But what we do want, we know their intersection point, and we know that TW and WV need to be congruent. So, I'm going to draw a line segment, and I'm going to name it TV. Okay. Then we're going to draw a line segment PQ. But how do we need to draw it?
So that intersects at point W.
Okay, what else?
Point W has to be at the very middle of
Okay.
line segment TV.
So we could say that W is the midpoint. PQ is the segment bisector. Okay. So here is PQ. Now, here's the important part. We've drawn everything we've needed to, but our work is not done. We need those lined things to show that W is indeed the bisector. Okay? You have to mark it on your diagram so that anybody looking at your diagram knows that that's the information. Okay? All right. Last thing, and then I'll get you to your homework. I am going to give you 90 seconds for you and your elbow partner to decide which one of these can be assumed versus not assumed. So what I'll have you do is put a check mark on ones that, yep, we can assume that, and put an X on ones that, nope, we can't assume that. What?
No, that's wrong.
Yep. Oh, you know what? I don't know if we've talked about this officially. These mean perpendicular.
No,
These mean perpendicular. That little weird symbol.
Yeah.
Perpendicular.
AB starts at
So check mark.
CD.
Oh, I got check mark.
No, that's
E, B,
wait, isn't it?
D.
Because to intersect
Yeah, because B's on both. Yeah, he's on that edge, but he's there.
points E, C, and D are not here. Isn't it intersecting when you're going through the
Oh! I thought it said coplanar.
I thought when you intersect something, it has to be
My bad, brother man. Okay, AB
between. So look,
is perpendicular to plane S.
it's coming in. This
No,
intersects.
I don't think so, right?
Has these symbols. So yeah.
Oh, I didn't.
I don't understand what you're asking.
Oh, okay then. But then CD intersecting plane T is not correct, right?
Yeah.
And then AF intersects BC at
would still
plane
be
B.
perfect,
True.
yep.
Yeah. Okay.
But
So
that's a
check,
completely
no,
different
check,
one.
no, check. Just gonna start on my homework. What's the homework?
All right. A, B, and F.
47.
Are they collinear?
Yes.
Yep, we can see them on the same line. Okay, what about E, B, and D? No, we do not see them on the same line. Is AB perpendicular to plane S? Here's AB, here's plane S. We see this guy right here. Yep. What about CD to plane T? You guys, here is CD, here is plane T. Is it marked? No, so we can't assume it. I'm so sorry. Okay, now, could we eventually have some theorems to help us prove that to be true? Yeah. That's where we're going. Okay, AF intersects BC at point B. True. Okay.